welcome to New Electronics World. Let's discuss about line chords. Okay, first of all, what is a line chord? Line chord is one that we use while transmission of a data from the transmitter to receiver. Okay, let's see. That is, it is a chord used for data transmission of a digital signal over a transmission line. First of all, we know that what is a transmission? A transmission means there will be a transmitter and there will be a receiver. Okay, there will be a transmitter as well as a receiver. I'll draw this here. This is a transmitter and a receiver part, and this transmitter will be transmitting signal to the receiver through the channel. This arrow mark that we can see in between these two blocks are known as the channel. Okay, so while transmitting through the channel, we need the chords called as line chords in order to transmit the data from the transmitter to receiver. Okay, that chords are known as line chords. Is it clear? Yes. It is chosen so as to avoid overlapping and distortion of the signal. We know that while transmitting a signal, we can see noise, attenuation, and many problems. Okay, in order to avoid all these things, that is overlapping and distortion, we have discussed about the Nyquist criteria, and also we have seen that when and where the overlapping will happen. Okay, so all those cases we have discussed. So it is very clear that all the overlapping can be avoided using the line chords. Ones and zeros will maps to different voltage levels based on some algorithm. Ones and zeros means the digital data. Okay, we will convert the analog signal into a discrete signal, and then it is converted to a digital signal. Okay, after the process like sampling, quantization and encoding, and we'll get ones and zeros. Okay, these ones and zeros we will maps to at different voltage levels. Okay, say if one is mapped to 5 volt, and 0 may be mapped to -5, or 0, like that we will be doing the mapping, and we will be transmitting the signal. While transmitting, we will convert this signal to ones and zeros into different voltage levels, and that is known as the line chords. These ones and zeros are known as the line chords. Okay, is it clear now? Yes. Now let's see the characteristics of line chords. First of all, the first and foremost one is signal level and data level. What does it mean by signal level? That is the number of voltage levels allowed in a particular line chord. That is, let's see with that an example. If this is a graph of I will do it with an example, sorry for the disturbance. Okay, this is the graph for 1 and zeros. Okay, 1 and zeros. This is 1, then 0 and 1. Okay, 1 0 1. Let this 1 will be 3 volts and 0 will be 0 volt. Okay, so let's think that this is a graph, and this have a signal level of 2. It has two signal levels. It has two signal levels. Why? Because for indicating 1 it needs 3 volt, and for indicating 0 it needs 0 volt. So the signal levels, that is number of signal levels required here, is 2. And data level, the number of values to represent data. Here we use only 1 and 0 for representing the datas. So the data levels are 2. Two data levels are there. So we can say there are 2 data levels as well as 2 signal levels. If the let's see another example, that is I'll use another color. Okay, let it be blue. Okay, if similar kind of graph to and I'll do it to place here. I will draw one. So this is 1 and this is 0. So yes, this is 1 and this is 0. So how can we explain this? Sorry, one mistake is there here. I forgot to draw. Yes, one thing. 1. This is 1. This is 0, and this is 1 again. Okay, if let it be 4 volt, and this is minus 4 volt, and in between this there is 0. So for indicating 1 we have 4 volt, and for indicating minus 4, sorry, 1 again we will use minus 4 or negative 4. So in this case, number of signal levels we use are, number of signal levels is, number of voltage levels we require is, it is 3. Okay, it is 3, and data levels that we use here is again 2. Data levels used is 2 and the signal levels used is 3. So for indicating 2 or 3 signal levels we can use 2 data levels or vice versa. So we have to think about that. Okay, that is one of the characteristics of line chord. Many other characteristics are also there. I'll show that. Okay, then next one is, this is fourth one. Yes, next one is pulse rate and bit rate. How can we say what is a pulse rate and bit rate? Pulse rate means number of pulses per second, and bit rate means number of bits per second. That is, what all are the number of pulses that we are passing in a second. So I'll do it with an example. Black color I'll take. Okay. I'm thinking about one number. Yes, I will draw one graph here. Here, this is 1. Okay. Then 1, 0, 1. Okay, 1, 0, 1. Okay, so and we can say the duration from another color have to be used is this duration, that is this, from this point to this point. Sorry, this is very difficult to draw over here. This is 1 and this is another one, 1, 0, 1. So from this point to this point we have a time interval of TB. Then what we can say is number of pulse which is present in this particular TB duration is 1. So what is the pulse rate here? Pulse rate is equal to 1 by TB. Okay, is it clear? Yes. In the similar case we can use another example. What is bit rate? Bit rate is same as that of that. Number of bits present in a particular duration, in a particular time duration of, or we can say is this is 1 and this is 1, 0, 1, and this time interval is taken as TB. So what we can say is, yes, the number of bits per second will be 2 by, sorry, pulse rate will be 2 by TB. That is 2 pulses are there in one time interval TB. Okay, it's very easy. It's only a fundamental kind of thing. Don't have to explain more about that. Then what is about DC component? It is a total area under a waveform. So let's have a waveform here, and is 1, 0, 1, 1, 0, 1. So what we can say here is total area. What is the total area here? Area under this and then area under this. So we can say here there is 2 units. 2 units. We have 2 unit of area under the waveform. So let's have another graph of similar kind. I'll draw this tab here and here, and one more here. Okay, what's area here? Here we can say this area under this and area under this. Togetherly it forms the area 1 minus 1 plus 1, that is equal to 1. The area will be 1, that is the negative part will be cancelled off. So that is DC component, the total area under waveform. Okay, then we can see the next characteristics, that is self-synchronization. What does it mean, self-synchronization? If receiver clock frequency and the transmitter clock frequency are not same, then the received data will be wrong. That is, if received clock frequency is 500 Hz and transmitter clock frequency is 1000 Hz, what will be the received data? That will be wrong because it is not of same frequency. In order to avoid this condition, the transmitted signal should contain the information about the clock. That is, the data that is being transmitted should be containing some information about the clock. That is from the transmitted signal that the receiver should be able to extract the transmitter clock. So if there is an error caused due to this particular condition, we will use the self-synchronization characteristics of the line code. Okay, that is nothing because it is a simple thing. That is, the transmitted signal will be containing the clock. Okay, information about the clock of that particular signal. Okay, that particular clock will be extracted by the receiver at the detection time. So that extracted clock will work together and will produce a correct output of the signal. Okay, the correct data that has been transmitted will be received at the receiver end by using this particular property or characteristic of the line code. That is the self-synchronization. The self-synchronization means in the name itself we can see that the the transmitted signal will be self. It will be itself. It have the information about the clock. That is the meaning self-synchronization. It will be self-synchronized with the clock. Okay, so what all are the points? Major points are, yes, signal level and data levels that we have discussed, and pulse rate and bit rate. DC component, it's the area. Then self-synchronization. I have missed one point, bit rate. Pulse rate I have explained. Bit rate means what? It is a number of bits per second. In 1 second, number of bits that has been transmitted in the signal. I think I have forgotten to tell that. Okay, yes. Then last one is self-synchronization that I have explained. So if you have any queries related to this, you just comment in the comment box, so that I'll be answering. And the remaining portion of the line code we will see in the next class, because we have the line code types to see. That's very important part and interesting part. This topic is most important part in this particular module, because line codes are very easy to study. Just by thinking in only, you can grasp the meaning of the line codes. Okay, the characteristics of line code may be a 5 marks question or 8 marks question in the question paper. So this points you have to remember, and the different types of line codes we will discuss in the next video, so that you have to very keenly study the line codes. Okay, hope you have understood the meaning and all the things I have explained here in this class. Okay, thank you.